In this video, we are going to discuss example 5.5 that talks about the temperature dependence of a light bulb's resistance. The question says a 100-watt light bulb is connected in series to a source of EMF with VEMF equals 100 volt. When the light bulb is lit, the temperature of its tungsten filament is 2520 degrees Celsius. What is the resistance of the light bulb's tungsten filament at room temperature, which is 20 degrees Celsius? Let us first write down what is given to us. We have the power P, which is 100 watt, VEMF 100 volt, and the temperature of the tungsten filament 2520 degrees Celsius, and the room temperature. We will denote the room temperature as T0. We need to find what is the resistance of the filament at the room temperature. So let the resistance of the filament at room temperature be denoted by R0. I will write this as resistance at room temperature. Its resistance at temperature T, I will write as just R. Resistance at temperature T. Before we find the resistance at room temperature, let us first find what is its resistance at temperature T. We can find that resistance by using the relationship between power, resistance, and VEMF. We know that power is equal to V square over R. So I can rearrange this term to find R. I can write R as V square over P. Just cross multiply the terms. When we substitute the value, V is 100 squared divided by P, which is 100. We get the resistance as 100 ohm. So this is the value of my R. I will call this equation 1. To find the resistance at room temperature, I'm going to use the temperature dependence of resistance equation. The equation goes like this. R equals R naught 1 plus alpha T minus T naught, where R is the resistance at the given temperature, R naught is the resistance at room temperature, alpha is the temperature coefficient, T is the temperature here, and T naught is the room temperature. If I want to find R naught, I will divide R with the rest of the term. So R naught will be equal to R over 1 plus alpha T minus T naught. Now let's substitute the value. R we calculated as 100 ohms here. So I will write it as 100. 1 plus alpha is a constant for the given material. They should give this to you in the question. Right now I'm going to find the value of alpha from the table here. So we will look for the filament which is made up of tungsten, and the temperature coefficient of tungsten is 4.5 times 10 to the power negative 3. So 4.5 times 10 to the power negative 3 into T, which is 2520, minus T naught, which is 20. And when you solve this, you get your resistance R naught as 8.2 ohm. This is the resistance at room temperature. So whenever they ask you to calculate resistance between two temperature values, this is the equation that you have to use. And it's a very simple equation. You just need to remember what each term represents. R naught is the resistance at room temperature and T naught is the room temperature. R is the resistance at any higher temperature other than the room temperature and T is that temperature.